This is Project 5 of the Arduino project book where we learn how to control a servo. In this project we make use of PWM, pulse width modulation, which we learned about in the last project, to control a servo, which is like a motor but can be controlled to rotate to a specific angle. The project also introduces capacitors and even got me looking into the datasheet of the ATmega 328P in order to get PWM working with the servo. The first thing I did was build the circuit, which uses lots of new components. This project introduces the capacitor, which is a ubiquitous component in electronics that serves many uses. One thing that they can be used for is smoothing out voltage fluctuations, which is useful when working with motors that, when changing from stopped and started states, can cause sudden drops or spikes in voltage. Capacitors are able to smooth sudden changes in voltage by their nature of acting as voltage reservoirs. When the input voltage rises, the capacitor begins to store charge, and when the input voltage falls, the capacitor begins to release energy, allowing the capacitor to fill the dips and peaks of the input voltage. One important thing to call out that the book does a good job in mentioning is that capacitors can be dangerous. The capacitor is a directional component that needs its positive and negative terminals connected correctly, or else the capacitor could explode. So, after carefully reviewing the book's circuit diagram and connecting up the servo motor to the board along with a potentiometer as an analog input for controlling the motor, my circuit was complete. So I'm making space for the capacitor to go in here. And the side with the black stripe, which I'm not sure if you can see there, but there's a small black stripe, that side goes to ground. The next step was to write the code to control the motor. The gist of the code is that the servo expects timed pulses at a certain frequency, and the width of those pulses determines the angle the servo will rotate to. To write this code, I again have to deviate from the book since I am using Rust along with the Arduino HAL crate, and I'm not using the Arduino IDE, which is what the book uses. With the Arduino IDE, I believe you can get a very friendly servo API that allows you to simply call a function to set the angle of the servo. However, the Rust crate I am using is much less abstracted and requires a bit of tweaking of the actual registers on the chip to send correctly timed pulses to the servo. I found this example code from the Arduino HAL repository on how to control a basic servo, and to my surprise, running that code basically worked. It required a little debugging of the max and minimum duty cycles for controlling the servo, but once I tweaked those values, I was done with the code for this project. The only thing was I still had no idea what this section of the code was doing. So let's go for it, I guess. Cargo, run. Oh! And there it goes. That's kind of awesome. Unfortunately, the comments in the example I found were not very descriptive, so I had to take a look at the Arduino HAL crate and the ATmega 328P datasheet to get some insight into what was going on here. Well, it's not my full goal to understand and describe all the details of the ATmega 328P in this introductory project. I still want to gain some understanding of what's going on here. First, we're getting a handle onto the timer peripheral associated with digital port 9. This timer peripheral is a small circuit that has a few registers we can use to modify the timer's functionalities. We need to make sure that the timer is in a PWM mode, which allows it to pulse at the correct frequency, and to do so, we use the Arduino HAL's crate provided methods for updating those registers on the timer 1 peripheral. I'm basically skipping over all the details and settings available on this timer peripheral, but for this intro project on introducing a servo, I think this is a good base level of understanding. So I did some debugging by printing out the duty value I was getting from the potentiometer and I found some new min and max duty values. And so now I think my potentiometer is more, it doesn't cause the servo to jump as much. Which is really cool. It's fun to play with. And so that's project number 5 on how to control a servo. See you in the next project.